The trigonometry of right triangles is going to be particularly important for us in our study of physics. The trigonometry of triangles in general is going to be very important, but the subset of right triangles when it comes to vector spaces and vectors is going to really be a key component of our study when we get to later chapters. And this is a subset because of the fact that we are establishing by definition that one of the angles inside the triangle is exactly 90 degrees. So we're going to set up our triangle here, and we will utilize this triangle for the remainder of our video here. It's going to be a right triangle as established by the indicator here, and then we're going to have side lengths A, B, and C. Now, we want to point out that the particular names here correspond to the hypotenuse of the right triangle, and that is side C that is opposite the right angle. It's important to keep that straight. So let's look at some general properties here. The first one that we're going to review is going to be one that is well known to you, I hope, and that is the Pythagorean theorem, which establishes the relationship between the sides of the right triangle. And that is, if we take the square of side A, add to it the square of side B, we will get exactly the square of side C. Now, this is a special case of something called the law of cosines, which we will discuss in a subsequent video. Next, we want to look at the interior angles of our right triangle. Now, we've already established this, that one of them is 90 degrees. Let me give you some notation here, because if you're going to study anything related to physics, you need to be familiar with Greek letters. This is the Greek letter alpha, the Greek letter beta, and the Greek letter gamma. We'll also use the letters theta and phi later on, but for our purposes today, this will suffice. So we have established that the angle alpha is exactly 90 degrees. And because we know that the sum of the angles, the interior angles of a triangle, must always add up to 180, we can stipulate now that alpha plus beta must also add up to be 90 degrees. I think I said this wrong. When the letter gamma, this is the angle gamma, is exactly 90 degrees, because 90 plus 90 gives us our 180. Trigonometric functions that we will utilize a lot over the course of this semester and next. We want to take a particular angle. Now, this would have worked with both angle alpha and angle beta, but we will take angle beta specifically as long as you remember the orientation of the sides. Now, the opposite side is going to be the side that is not connected in any way to the angle. And so in the case of angle beta here, the opposite side is going to be side A. And so when we construct the trigonometric function for the sine of angle beta, it is the length of the opposite side divided by the length of the hypotenuse, which is C. Okay, and so we see that the sine of the angle beta is the length A divided by the length C. The cosine function is the adjacent side. Now, the adjacent side is defined to be the side that composes part of the angle that is not the hypotenuse. And so the cosine function is constructed by taking the length of the adjacent side, in this case B, and dividing it by the length of the hypotenuse. And so for angle beta, the cosine of beta will be B divided by C. The third function, by far not the last, but the third of the three we're going to talk about here, is the tangent function. And the tangent function, because of the composition that it is a very important function in the study of trigonometry-based physics. And it is defined as the opposite side divided by the adjacent side. And so in this case, it will be A over B. And so in summary, our properties of right triangles that we want to remember are the Pythagorean theorem that a squared plus b squared equals c squared. The sine of a particular angle is defined as the opposite side divided by the hypotenuse. In this case, that would be A divided by C. The cosine is the adjacent side divided by the hypotenuse, in this case b divided by c, and then the tangent is defined as the opposite side divided by the adjacent side, in this case a over b. And I mentioned earlier that the tangent was very useful because of the way it is composed. The tangent is also arrived at by taking, if you know the sine of the angle and the cosine of the angle, you can divide sine by cosine, which would, in this case, would give us a over c divided by b over c. When you divide by a fraction, you multiply by the reciprocal, so we flip the second one. The c's cancel out, and you are left with a over b. And that is indeed the tangent function that we had previously specified. Trigonometric functions also have inverses, and so if you know a particular value, you can take the inverse of that trig value and arrive at the original angle. And so you have the inverse sine, the inverse cosine, and the inverse tangents for all of our functions. What you do to one side, you have to do to the other. And so in this case, you would have the inverse sine of the sine of beta equals the inverse sine of a over c. The inverse sine of the sine cancels out, leaving you with just the beta. And on the right-hand side, we have the inverse sine of the quantity a divided by c, of which your calculator is perfectly capable of doing. And likewise, logic gives you the inverse functions for the cosine and the tangent.